Hello everyone and welcome back to another video, and today I'm just kind of showing off a kind of stupid idea, and that stupid idea is LGA 775 direct die. So let's make the test bench a bit bigger, and well, the system's already running so you can't really see that much, but basically the backstory is I got myself a delid die mate to delid my 8700K here. Because my 8700K started overheating. It used to run 5.2 gigahertz, like stable-ish, like it could play games and run Firestrike. It would occasionally crash in time spy, so not fully stable, but like stable enough to actually just like use it daily, but just like not render videos on it and stuff. Yeah, so like I started having issues that it crashed and overheated, and it got so bad that even at like 5.1, sometimes even at 5 gigahertz, it would instantly crash. And yeah, and I took a look at my temperatures, and I was just like, that's way too damn high. So yeah, I decided to delid the CPU because I never did that. I first put paste back on, then the CPU started doing 5.2 again, and now I put liquid metal on it, and now it does 5.3. Potentially even more. I just did a quick test, and like it's stable, like it does 3D Mark 11 at 5.3, and as like from all my testing, 3D Mark 11 physics is the hardest one to pass, like harder than time spy in my experience. So if it does 5.3 in that, it like probably does 5.3 in everything. Yeah, though I haven't done any proper test, like stress testing, which I don't think I'll ever do, because like my 5.2 overclock was so damn unstable, and I never actually had any crashes playing games, so like, I'm gonna do a told you so to myself if I should have crashes like doing stuff while doing like running the test bench. But anyway, let's get to this piece of junk. So the thing with the delid die mate, I got the Debauer one, is it also fits 775 CPUs because their footprint's basically the same. Now I had one issue where like some 775 CPUs have a not as tall IHS, and I actually got my delid die mate stuck on one of them and had to use a water pump wrench to like get it off again. But the other 775 CPUs were delided like a champ, like it went really well, and this right here is one of them. So this is a Xeon E5472. This is a quad-core Xeon, so it's one of the funky ones because it has two dies. So if you didn't know, Ryzen wasn't actually the first time that like consumer, well technically this is a server CPU, but like this is a 7.7, like you can mod the Xeons to run in normal consumer boards because they're basically just the same CPU with a different name. So technically this kinda is a consumer CPU with multiple dies on it, because the quad-core CPUs just have two core dies, and they don't have an I/O die like Ryzen because the I/O die is here in the North Bridge. Like the memory controller on LGA 775 is not in the CPU, it's in the North Bridge. And then I think with X58 it became integrated into the CPU, so there's like no I/O die on these. But yeah, and so I got a little bit bored and carried away, and I was just like, hey, I have these LGA 775 CPUs that I don't really do that much with, especially the Xeon, because my usual test bench, like my usual board to go to for LGA 775 is a P5E/Rampage formula. That one's based on X38, and X38 doesn't run X or E5 like 5000 series Xeons like this one. You need a X48 or P45 motherboard, which is this one. The problem with this board is you can see there's only one RAM stick because the left memory channel is hella dead on this board. And just generally this board is kind of crap, but it's the only board I have that runs my quad-core Xeon. So I was just like, I have the CPU I never do anything with, I have this board I never do anything with, let's do something stupid. And that something stupid is direct die cooling. So you can actually modify the LGA 775 socket to run direct die. It doesn't necessarily work on all the CPUs, because it's a bit tricky to get them to work. So this right here, like this is the IHS. The CPU was actually soldered, but like it's really bad solder. So yeah, so you can see there's two dies on this thing. And the way how you make this DirectX compatible is like you take this bit of the ILM off, like you bend this little tab up, then you can just take it off. And then it basically fits DirectX. Now you can remove the entire ILM. You can see there's little lever mechanism thing is still on here, but it's actually fouled enough so that it doesn't interfere with the block. And the one issue you might have is if you have CPUs that have thinner dies than this one, you might not be able to get contact because the metal frame that's still on here is like almost as high as the die. Like there's barely any space left. So if you have a CPU that has a like thinner die, you might not get contact. But this one has contact. So let's switch back to the OS. I actually noticed core temp is like bugged. Like, let's say core temp and hardware info, and let's put it somewhere where I can actually see it. So core temp saying we're at like 50, mid 50s or low 50s. And hardware info says we're like in the 40s. So who do I believe? Like, core temp just kind of, yeah, it just kind of reports temps that are like way higher than hardware info. And I tend to believe hardware info more. But like core temp usually is like very accurate, except on this thing. Which might be due to, oh, I have an ambulance go by again. Which might be due to it being like a Xeon that's modded to run on a consumer board. But like hardware info got it right. So yeah, so if we start IDA 64, just stress test, this is completely stock. And yeah, I mean, temperatures look pretty good with our averages are, well, for now below 50. But actually, it's gonna be like low to mid 50s, I think, if we let it run for a while. If you believe hardware info, that is. Core temp says we're like in the 60s already. And yeah, so I don't entirely know who to believe. But for stock, at least, both temperatures are very acceptable. Like, is there actually power measurement in this? It has a VRV out sensor. 35 watts? That seems very low. Isn't this a 95 watt TDP CPU? Wait, does it just not have a TDP? Man, I haven't done enough LGA 775 stuff to like remotely know what this is. It doesn't show a TDP. But like it's a quad core. And like it's a 3 GHz one. That's like, I think, well, I think that's faster than 3 GHz. But like as far as the server CPUs go, I think this is like the upper end of like how fast you can get them. At least for stock speeds. Like this can overclock like 4 GHz easily. If my RAM would do it, that is. Like I can't really overclock here because this board is so bad. Not just is the left memory channel dead, the right memory channel is extremely picky. This is the only RAM stick that it reliably works with, and this is like some trash 800 megahertz like green PCB stuff. And at stock FSB, this is already at 800 megahertz. So like there's no overclocking headroom left in the RAM stick. So I can't really, like, I'm already at 400 megahertz FSB, I can't really go any higher. And I can't select a slower speed than, like, you know, like we are already at DDR4, at DDR2 800. Yeah. I also have no idea what memory chips this is, like, literally no idea. Yeah. But, I don't think this is very accurate. I think we are consuming more power than that. This is... I think this is just I2C. I think it's just grabbing that over I2C from the vCore controller. Like the ASP0800. Like the VRV out thing. If you have a VRV out sensor, that usually is like very accurate. Because like, as far as I know, this is just directly from the controller. Like this, wherever, like this is from the, you know, from the Super IO. That tends to not be very accurate. that tends to be more accurate, at least for what the VRM is outputting. What the actual die senses, that's a different story. But I kind of have a hard time believing this power figure, because like we're at full load, 4 cores, like 3 gigahertz. We're not running that much VCore, to be fair, but like I think we had more than 40 watts. So yeah, but you can see temperatures. Oh, also this believes hardware info. This also says that core temp's overreacting because it's nowhere near 60. So I guess we can just ignore core temp. Yeah, like you can see at stock speeds, like back in the 775 days, this would have been a really fast CPU, I think. Like having a quad core back then was a pretty big deal, and a 3 gigahertz one at that. Like I think most CPUs came in like 2.1 to 2.8 gigahertz. Yeah, but like the one problem is, so direct die is kinda like, you know, it's kinda cool, but in my experience, like from what I've seen, in my experience is kind of a stretch. I've only liquid metalled one CPU, that being my 8700K, and I did it yesterday. So I don't have that much experience, but from seeing people do direct die and do liquid metal on CPUs, what I've seen, actually, yeah, we can't actually do anything more, so I just left this on auto. What I'm just gonna do is set this to 1.5 volts, because I think that's like towards the upper end you're gonna run on 775. And I'm gonna show one of the potential problems. So, the thing with direct die is, yeah, you're cutting out the IHS. There's less layers of thermal transfer that you have to go through. Like your block directly cools the die, just, you know, like how it is on a graphics card. And like delidding, like GTX 580s, for example, helps a lot. So you would think that direct die on a CPU also like helps a lot. And in theory, yes. There's some problems. And I'm not like pulling that out of my ass. Like for example, Debauer made a direct die 11900K video, and his direct die results were worse than IHS and liquid metal. And that's a thing that I've seen multiple times, where direct die is not just a bit, it's like consistently, measurably worse than just liquid metal under the IHS. And I don't exactly know why that is. My explanation, and you see with all my throttling. So, my explanation for why this is a problem. There's like multiple theories I have. The first theory is, a CPU die is pretty small, and like while they consume nowhere near as much power as a GPU die, the power per square millimeter thing for CPUs is, I think, still like worse than GPUs. So there's more heat in a smaller area on CPUs, which means that getting that heat out of it is like actually kind of hard. Like that's one of the reasons why Ryzen 5000 runs so hot, because the cores are so small, and you can push like my 5800X has only one CCD, like one 8-core CCD, about the same size as one of the dies on this CPU, and it has 8 cores in it, and you can put like around 180 watts through it, even if the CPU is soldered. Like, it's pretty hard to get all that heat out of it, and the 5800X 3D is even worse, because that one has much higher effective cycles. Oh, we have a temperature probe at -40, that's cool. Yeah, so like you can see it's thermal throttling. So even though at stock it seems pretty good, yeah, this is not all that great actually. Like that's kind of why I said it's like kind of a stupid idea, because this is kind of what I expected going into it, because direct die has these problems. So like the first theory as to why it has problems that I can think of is like the die is just too small, you know? And the heat spreader, it says it in the name, it's supposed to spread out heat, because an IHS is a much much larger contact area than just on the die itself. And I can't say why, but I feel like the IHS is better at pulling heat out of the die than like just any standard water block that you have. It's potentially much flatter, it's potentially better mounting, like better mount. I don't exactly know why. But I have a feeling like the IHS is just better at getting heat out of the die than just a direct water block. One of the potential reasons for why that is also like not this block actually. I actually swapped to this block from the other one. Like I had a freeze mod block before, specifically this one, like there. So I had this one before, which like looks a lot more fancier. Like it has a jet plate and stuff. This one doesn't. But at least on the 8700K, this one is like a lot better. Like the freeze mod block would thermal throttle, whereas this one only hits like 80 degrees. And one of the reasons, I think, is because I lapped this block, and the freeze mod block actually has a cold plate that's not very flat. It has like very like easily visible machine marks. And actually a lot of water blocks look like that. Like for CPU blocks, like I think EK does that, I don't know if Corsair does it. Like a lot of CPU blocks seem to just come with these big machine marks. Like they're not very, very flat. Like they might not be like curved or anything that much, but they have a rough surface basically. And I think that just leads to like, you know, bad contact on the die compared to an IHS. And you know, it's not that big of an issue if you have that same block on an IHS because that's a much, much bigger contact area. And yeah, that's like, I guess my theory as to why direct die is worse. Like just kind of the mount is worse, I guess. And there might be some fancy thermodynamics involved with like how an IHS might be somehow better than just a direct block for pulling out heat. But I think mainly, just the mount tends to be worse if you go directly with the block. And also, like, well, and there's also the thing, if you go liquid metal under the IHS, liquid metal is better than thermal paste. And I think liquid metal plus IHS plus thermal paste is still better than just thermal paste, because, like, the liquid metal is so conductive, like, it's basically not even a full layer of transfer. And then again, you have the IHS that's connected so efficiently to the die now with liquid metal. It makes the surface area so much bigger that it just works better. You know, you effectively increase the size of your CPU by having a heat spreader that's just very efficiently connected. So that, yeah, that's also gonna be a factor. So, yeah, that's kind of the thing I've seen. So, yeah, direct die just usually doesn't really work that well. It might work for like HEDT CPUs with like massive dies. That might be a different story, but for like, you know, consumer level CPUs that have like small-ish dies, I think I've never really seen direct die be like measurably better than just putting liquid metal on the IHS. And given that direct die is like harder to pull off, like you have to modify the socket and that stuff, and like you might have to get like a custom retention frame, like I think it's just not really worth it. Which is why my 8700K is staying with liquid metal IHS. I'm not direct dyeing that one. But yeah, so that's just kind of the thing I wanted to show. It's just like partly why I think direct dye isn't really that great of an idea, and also partly just like, hey look, I did it anyway on LGA 775. And at least for stock it works kind of well. With admittedly 1.5 volts is kind of a lot, and we are on a quad core. So yeah, it does get quite hot. But again, this is the same loop that can keep my 8700K at 5.3 gigahertz, like 1.4 volts I think I ran. That one like only goes into the 80s. And this is like hotter than that. Yeah, this one went over 80 degrees. At admittedly more voltage, but like this is only a quad core, and like 775 CPUs don't consume that much power to begin with, compared to like modern Intel chips, like the 40 nanometer chips. But anyway, I think I've rambled on for long enough. Yeah, already 20 minutes. Yeah, this is not a very high production quality video. It's just, hey, look, DirectDi and rambling about DirectDi. Anyway, goodbye.